In the last video, we wrote some code to find just the red square isolated from the other shapes of different colors that we drew on our board. In this video, we're going to find the actual pixel location of that red square. The first thing I'm going to do is scroll back through my code and make sure that I have semicolons on any of these places where I'm calculating a variable, because I no longer want to see those things printed out to the screen. There we go. Now, in order to calculate the location of the red square, the first thing I need to do is sum the pixel values of each column of the matrix that is representing the image that shows just my red square by itself. So as a reminder, this is the image that we have. We know that the pixels of this square are higher value pixels, while all of these dark pixels have a value of 0. And I want to find the location of the center of this square. So the first thing we're going to do mathematically is sum the value of each of these columns. I'm going to create a variable called column sums. And for this, I'm just going to use the MATLAB function sum. The function sum, when we give it a matrix as an input, creates a vector that is where each element in the vector is the sum of a column. Once I have those column sums, I want to multiply each of those sums by the number of the column that it represents. So to do that, I need to create a vector that just gives a number to each of my columns. I'll call this variable column numbers. This vector will start at 1 because that's the number of my first column. The vector will increment by 1 each time until it gets all the way up to 640, because if you recall, 640 is the number of columns that we have. I now want to take each of the column sums and multiply it by the number of the column that it's in. So we'll do that. Let's create a variable called column mult, because this is the multiplication, and that will be equal to column sums. I'll use dot times. Dot times in MATLAB means that I can take two vectors and multiply them element by element. So the first value in column sums vector will be multiplied by the first value in the column numbers vector. And then the second value will be multiplied by the second number, and so forth. Once I have this, I want to add all of those values together. I'm going to call this column total. And it will be equal to the sum of column mult. Now, there's one last thing I have to do here, and that is to take my column total and divide it by the total value of all of the pixels in the whole image. Once I do that, it will tell me the column location of the red square. So we'll create a variable called column location, and that's equal to column total divided by the sum of the sum of red only. So my first sum here will sum up the columns, And then my second sum will sum those up to give me the total value of all of the columns. And I'll delete the semicolon here so that when I run this, it will tell me the column location of the red square. So let's test this before we go on. I'll start by closing all of the figure windows that I have open from the last time I ran this program. Especially, I'm going to make sure to close the live video feed. Then I'll run this. There's the red square, and our column location is saying that the center of this square is located at pixel 231.7743. Now we know that we can't have a fraction of a pixel, so the center of this would be at somewhere like 231 or 232. Let's check to see if that's correct. I'm going to take this thing up here where we are plotting the red only, and I'm going to cut it, and I'm going to put it down here. And after this IM show, I'm going to type in hold on so that it will not wipe this picture clean when I do my next plot. I want to draw an X at the location of the square. So I have to give an X and Y location for where to put the X. The X location of this X that we're going to draw will be the column location. I haven't yet figured out what the Y location is, so I'm just going to draw the X in the middle of this screen. Now we know that we have how many rows? We have 480 rows. So let's make the Y location be halfway up. 240 is halfway up. And I want to draw an X, and let's make it a red X in that location. I'll close all of my figure windows. Oh, and I'm also going to type in hold off so that we turn off that hold after we're done with this plotting. Now let's run this. So this red X is plotted halfway up in the vertical direction, and it's plotted left to right in the location detected as the center of the square. So that's pretty good. That's pretty close. Let's go back and see if we can now find the actual location of the center of the square, top to bottom. Let's take this whole calculation that we did for finding the column value of the center of the square, and I'm going to paste it. Now instead of column sums, we're going to calculate row sums. And I'm going to, after red only, put a single quote. This will take the red only matrix and it will turn it on its side, so that when we use the function sum to calculate the sums of the columns, we'll actually be calculating the sums of the rows, because we've turned the red only matrix 90 degrees on its side. Now, instead of column numbers, we'll call this row numbers. And instead of going from 1 to 640, we're going to go from 1 to 480, because that's the number of rows that we have in the image. Now here, instead of column mult, I'll make it row mult. And instead of column sums, we'll make it row sums. times row numbers, and then row total, now we have not only the column location, but also the row location. Let's make sure all the figure windows are closed before we run this. And here we've found the center of our red square, so it appears to be working correctly. Let's do a little bit of experimenting to see how this approach to finding the location of an object can go right or go wrong. I'm going to go back to my live video feed here, and I'm going to take my red marker and I'm going to draw some other red object down here. So let's suppose that we have two red objects in the image. Let's see what will happen when we try to find the center of the red object using our approach. Both red objects are found, and the center of the red objects is found roughly halfway between the extremes of these two objects. So we haven't actually found the center of any particular object, we found the center of the red objects as a whole. Now, what if we want to find the center of the green or the blue object? Let's see if we can do that. Back up here where we're calculating red only, I'm going to create a new variable called blue only. And I'm going to use the blue only in our calculation. Also, I'm going to go back up here, and these previous figures, I'm going to comment them out so that we don't have so many figures opening up every time. And now let's run this and see if we can find the center of the blue object. There's the live video feed. There's our full color image. And here's the blue object. So we were successful at finding the blue object as well, even though the blue object doesn't show up quite as distinctly as the red objects. Let's try the same thing with the green. The green object is detected even less than the blue object was, but still our method was successful in finding the location of the green object. So color detection tends to work well when the object that you're looking for is a particular color and there are no other objects in the field of view that have that same color. But as we saw with the multiple red objects, if there's more than one object of the same color in the field of view, this method tends to fail.